Now we're going to go up into the antenna surface itself. We can trace the ray path from distant radiation off the antenna, the subreflector, and down the various horns. To do that, we go up this ladder, open up the hatch door, and pop up on the surface of the antenna. Nothing more that needs to be done. The safety, and up we go. I've done that so many times, it's second nature. So this is a 25-meter paraboloid, and the paraboloid works the same way for all. The radiation comes in from the direction the antenna is pointing, strikes the surface. In this case, it runs up to that subreflector, that conical-shaped, asymmetric subreflector. And from there, the radiation is down in a cone to go in one of the 8 feeds. We change frequency by rotating the subreflector, so these feeds are not on the optical axis of the antenna, but they're arranged around a ring called the feed ring, and we can illuminate any one of them at a time. So that's the reason why we normally can observe only in one wave band or one receiver band at a time. So the 8 horns that you can see there, they're all different sizes. The larger the size, the longer the wavelength. So the big one is what we call L band, 1 to 2 gigahertz. That's 30 to 15 centimeters radiation, which goes into that horn by appropriate rotation of that subreflector. If we're interested in 2 to 4 gigahertz radiation, then the subreflector is rotated by 180 degrees and the radiation goes down that second largest feed horn called S band. And so on and so forth with the other 6 receiver bands. By appropriate rotation of the subreflector, the radiation from the direction we're interested in will go down through the horn and into the receivers. Each of these horns is covered with this white window material. This is for weather purposes. It's not necessary for the function of the horn. This is to keep rain and snow and dew, bird droppings, and everything else out of these horns. There's a little bit of loss associated with that, but that's just something you have to accept. The funny inverted shape objects that are above the smaller horns are all heat lamps. We don't want dew or frost forming on the surfaces, especially at the higher frequencies or the shorter wavelengths. So when the dew point and the temperature are close together and sufficiently low for us to determine that dew is forming, the computer recognizes these combination of conditions, turns on these heat lamps, which warms up the surface and prevents frost and dew from condensing on top of these weather windows.